Alright, okay, so hello dears. Ayan, so welcome to the third video of our lecture on permanent stain smears. Okay, and for this lecture, what we're going to talk about is the iron hematoxylin stain and our lab procedure, our lab activity in our class, okay, under normal circumstances. Okay, I don't know if makashoot pa may video ba ani sa demo, but hopefully good makashoot pa may. Hopefully ma-okay na gyud makabalik na sa AK, kaya na pa other videos like concentration techniques na wala pa video, and diba? So hopefully let's pray for the best. Okay, so again, the iron hematoxylin stain. The iron hematoxylin stain is considered to be the oldest method because it was created over a century ago. So it's one of the stains that were used for staining parasites, one of the earlier stains, okay? But it was more difficult to perform, okay? Alright, and this stain reveals excellent morphology of your intestinal protozoa, and in some cases also the nuclear detail, alright, the nuclear karyosomes, nucleus, whatever, they are much more stained. They're considered to be much more, they're considered to be stained much clearer and sharper than using trichrome, diba? So that's for iron hematoxylin. And as mentioned, it's also a very good stain for fresh PVA or staph preserved fecal smear. So very versatile, yes, versatile. A lot of specimens can be used. Okay, all right. Ayan. So we have here the modifications. We have two types. You have the Spencer-Monroe and the Tompkins-Miller method. So we'll look into the different methods later. Now for our materials, as you can see, very straightforward. We need the slides, your sample, your applicator stick, the stain itself, iron hematoxylin, and a fixative, which is your PVA. Now we go into the procedure. The procedure that will follow, no, in our lab activity is the Spencer-Monroe method. All right, and we'll start first with the preparation of your fecal smear by starting first with placing your stool sample, fresh stool sample in PVA for 30 minutes or even overnight to fix it, diba? Fixation. And then after overnight fixation or 30-minute fixation, we then get a small portion and then we smear, okay, slide, and then using an applicator stick, we smear, alright? Thin smear, spread over the glass slide by rolling the applicator stick, and then we then let it dry, pwede rin overnight or at 37 degrees Celsius incubator. If you want to hasten or rapid ang pag-dry, you can put it in incubators. Okay, alright, so here's an example of the picture. Ayan, so your sample, your PVA fixed sample, either 30-minute ba or overnight, okay, and then applicator stick, roll, okay, and here is now your fetal smear. Alright, so that's the first thing we do. Okay, next is for our staining. For procedure for Spencer-Monroe, we have two methods because it would depend if the fixative that we use has mercury, example PVA, or non-mercury. Okay, so we'll start first with the reagent, 70% alcohol. Both of them, you will start with 70% alcohol. What's the purpose? For removal of fixative. Still the same purpose with your with the one in Wheatley's trichrome, diba? All right. Next, the next procedure now is for mercury-based. As you can see, it follows also the Wheatley's trichrome. You then immerse the slide in a solution of alcohol and iodine. Again, what's the purpose? For removal of mercuric chloride. Again, that's for fixatives that has mercury. Example, PVA, Schodins, diba? Alright. Okay, next, sa may next ani, your 70% alcohol because we then remove iodine. Okay. Alright. And then, next, we then rinse with tap water, which is now the next procedure for the non-mercury-based fixative. So if you use formalin ba, MIF, tama ba? MIF, mga staph na walay mercury based reagents, no? So you then diretso ka dayon sa rinse with running tap water. Diba? So very short, very madali for non-mercury-based fixatives. The difference lang yun for mercury-based fixatives are these reagents. You've always remember that the next reagent after alcohol is alcohol and iodine. Why? Because you need to remove first mercury chloride. After that, after removing mercury chloride, you then add another alcohol. Why? For removal of iodine this time. And then next procedure, same now with the non-mercury based, you rinse with running tap water. Okay. And then after rinse with running tap water is the stain itself, iron hematoxylin stain. Okay. And then next, your 70% alcohol. It follows na the rest of the procedure similar with your Whitley's trichrome. Dehydration, dehydration pa rin. Again, to remove water for dehydration. And lastly, xylene. Basta xylene, usually press the buzzer, that's for clearing, to remove the remaining alcohol. And then after xylene, usually, we then let it dry na, okay, and then we put the cover slip. We put the mounting medium like nail polish, U-kit, kato akong i-spell diri, and then we then put the cover slip, okay? So that again to preserve for a long time. Okay? Alright, ayan. So that's the procedure for Spencer Monroe. Now for Tompkins Miller, there's a modification. So this is again based on your Zybig na book. You have an additional 4% ferric ammonium sulfate which serves as your mordant fixative. Now what do you mean by mordant? Okay. Later you also know later ko na lang i-discuss sa acid fast. Okay. Mordant. Okay, later na yan. Later na. Okay. So 4% ferric ammonium sulfate. You also have 2% phosphotungstic acid which serves as decolorizer. Later, again, I'll check on that in acid fast staining. And then you also have lithium carbonate for dehydration, and then clearing. So the same xylene substitute. As you can see, it's put there, no, it's stipulated there, xylene substitute. Why? Because xylene in itself is carcinogenic, okay, and it's really harmful then to the health of laboratory technicians. So for those who are working in the histopathology section of the laboratory, histotech, it's they're very much prone to mga carcinogenic materials like benzene, xylene, mga yes, different alcohols put, so it could be really hazardous. So you are exposed to a lot of chemicals, reagents in tissue processing if you are assigned in histopathology subsection of the laboratory. So you have to be very careful. Okay, always wear your PP and all that. Okay, alright, ayan. And 17, preserved slides, mounting fluid, diba? Pwede siyang, again, as I mentioned, what we use, nail polish or U-kit. And then once the cover slip is intact, it's dried, we then examine them under the microscope. Ayan. So that's for Tompkins Miller method. As you can see, mas na-add. You added 4% ferric ammonium sulfate, which is for mordant, which again ako i-discuss later. And also 2% phosphotungstic acid, which serves as a decolorizer. Tama, decolorizer. Tama ba? Yeah, decolorizer. Okay. Alright, ayan. So, later, ito na i-discuss sa acid fast. Mas, ano dito, mas, ano siya, mas applicable sa acid fast. Okay, alright. And, yeah. Very good is the advantage of iron hematoxylin because, very good advantage is that it can produce, again, as I mentioned, good staining results, even if the one who performed the staining is unskilled, like first timer like us or mga beginners pa lang. All right, so it's not that technical compared to Whitley's trichrome. Okay, so that's a good advantage of iron hematoxylin. Okay, all right, and now we go now to the results, expected results of iron hematoxylin. This is how we report it. For positive, other than Blastocystis hominis, we then say positive for the name of the parasite and its stage. Example, positive for Entamoeba coli, cyst, and trophozoite. For Blastocystis hominis, we quantitate. So it's either rare, few, many, or moderate many. So it was not stipulated kung how many ang rare, few, moderate, many, but it's established per laboratory. Okay, so example, 0 is none seen. Tapos 1 to 5 ba ang rare, tapos 6 to 10 ang moderate, ay few, tapos 11 to 20, o 21, greater than 21 ba ang many per field na imong makita. Alright, so example lang siya. So it's established per laboratory, okay? And wala ko ka-search ani do sa books na to for blastocystis. So we quantitate blastocystis because again, if I'm not mistaken, quantitation of blastocystis will help us determine the severity of infection, if it's really like severe, or like it's just light lang ba, or commensal lang siya, it's not really the cause of infection. If I'm not mistaken, for Blastocystis hominis. Okay. And negative, non-seen. Okay. And the manner of reporting is also same for trichrome staining in our last video. Okay. And for the appearance, for protozoa cytoplasm, it's blue to purple. Okay. The protozoa nuclear material is dark blue to dark purple. So it's different from your weakly striped chrome, di ba? Ang nuclear material sa weakly striped chrome is red, purple, di ba? And the background material is light blue, sometimes with pink tint. Whereas for weakly striped chrome, ang iyang background is green. Okay, di ba? So that's for iron hematoxylin. So here's some of the pictures. Ayan. So as you can see, blue background with a pink tint. And then you have here Entamoeba histolytica. As you can see, the nuclei are color blue, di ba? Or purple ba to? Blue. Okay, and we have here Blastocysts hominis, vacuolar forms. As you can see, the background is still bluish, na pagka-pink. And then you have here the Blastocysts hominis. So we then quantitate that. Okay, based again on the given quantitation scale or grading of your laboratory ba? Alright, okay. Ayan, so should I discuss blastocysts? No, it's a lecture na. I think na-discuss na naman Bernal. Okay, so this is the vacuolar form. Your blastocysts vacuolar form, ganun siya. Tapos may mga nucleus dyan. Ayan, so vacuolated ang form ni that's the vacuolar form. Not sure other form. I forgot the name of Blastocysts hominis. Okay, all right. Ayan, that's for iron hematoxylin. Now we go to the last staining procedure. But before we proceed to the last staining procedure, which is modified acid fast, I will discuss a little about, not a little, but medyo marami-rami about acid fast staining, because so that you will understand why is it called modified. Because of course, modified naman siya. So of course, na siya original, which is the acid fast. Okay? Ayan. So that's what we're going to discuss. For principle of acid fast staining, acid fast staining is another routine staining method used for bacteria. Okay? Do you recall what type of staining technique in terms of method? Is it simple, differential, or special? It is a differential stain. Why? Because it divides the bacteria into two groups. It could be acid fast or non-acid fast. Now, what is the principle of acid fast? Certain bacteria, parasitic cysts, ayan, that's where we came in the picture for para, and rare fungal forms also. Their cell wall, they have what we call long chain fatty acids, okay, or also known as your mycolic acids, or also known as, daming AKA, hydroxy methoxy acids. Please take note. Ayan. Hydroxy methoxy acids. Okay, so sila. That's the other name. Mycolic acid, long chain fatty acids, hydroxy methoxy acids. Okay. Now, tama. They have these acids, long chain fatty acids, in their cell walls. Now, during staining, okay, part of the procedure of acid fast staining is we then add what we call an acid alcohol, okay, which serves as a decolorizer, okay. But during decolorizing, the carbolfuchsin, which is the first stain that we apply, because again it's a differential stain, so we use two stains. The first stain that we use is carbolfuchsin, okay. Now carbolfuchsin, because of the long chain fatty acids in their cell wall, they will capture the carbolfuchsin, they will hold on to the carbolfuchsin, the long chain fatty acids will hold on to the carbolfuchsin. That's why pag add sa acid alcohol during decolorizing, the carbolfuchsin will not be washed out. Ma-retain lang siya. That's why it's called acid fast. Okay, fast siya mugunit. Okay? Acid fast, yeah, acid fast. So, it's able to resist decolorization by the acid alcohol. Okay, alright. So, later you'll understand more. Okay, alright. And we use this again primarily for mycobacteria. Your Mycobacterium tuberculosis. Or the causative agent of course, huwag na mag-isip, para kanino yan, is of course, the causative agent of your tuberculosis. Nasa pangalan na, Mycobacterium tuberculosis. They have these long-chain fatty acids. Primarily used, the acid-fast stain, the true acid-fast staining procedure is used for the diagnosis and identification, detection of your mycobacteria. Okay, specifically for tuberculosis. Okay, alright. Once stained, they retain again that stain and cannot be decolorized even with the acid. Thus, they are called acid fast. Meaning, paspas kayo sila mo resist. Okay, makuha rin nila. Ilarang ma-retain ang carbolfuchsin. Gunitan nilang maayo. Char, sana all. Okay, alright. Ayan. And lastly, non-acid fast organisms, kato mga walay long-chain fatty acids, those organisms that do not have these long-chain fatty acids in their cell walls, they of course will not retain carbofluoxetine, okay, but they will then take up the secondary stain or counter stain, which can either be malachite green or methylene blue. So if methylene blue ang imong gamiton, which is the normal stain that we use, the secondary stain, the non-acid fast organisms and the debris, the background will appear blue, okay? And for methylene, for malachite green, as sa pangalan na, the non-acid fast organisms and the background will appear green. Okay. Alright, ayan, sige. Okay, ayan, sige Mark, kaya mo to. Alright, so this is an example of, again, Mycobacterium is the true acid fast. Siya jud ang daghang contents, okay, sa ilang cell wall. Marami siyang long chain fatty acids. That's why it is considered as a true acid fast. And we have what we call the partially acid fast. You have Nocardia, Legionella, Mycdade, which are, again, these are bacteria, okay? And you have oocysts of, ayan sila, Cryptosporidium, Cyclospora, and Cystoisospora. Remember, familiar, these are your coccidians, diba? The coccidians, okay? Alright, the coccidians. Again, still protozoans, diba? Coccidians. They are what we call partially acid fast. So when we say partially acid fast, they have long chain fatty acids in their cell wall, but in much lesser content, okay? Compared to your Mycobacterium tuberculosis or Mycobacterium species that in their cell wall, they really have a lot of long chain fatty acids. But for partially acid fast organisms, example, these organisms here are parasites, very important, okay? That's where we come into the picture. They have long chain fatty acids on their cell walls, but in much lesser content. Okay? Alright. Okay. So therefore, since partially lang, they're not really totally red. Okay? Or they cannot hold on to all of the carbofluoxetine. Okay? But it can still be stained by the carbofluoxetine. Sige, later. There's a diagram. So here's an example of a picture. Ayan. So the red ones are your Mycobacterium tuberculosis. And these are your Legionella Mycdade, as you can see. It's much less red compared to your Mycobacterium tuberculosis. This picture, guys, is from a real sample. When I was an intern in Galeares, I was able to picture, yes, this result in our microbiology, when I was assigned microbiology, when they were examining acid-fast slides for tuberculosis. So, in your bacteriology, you'll know that there's a grading for that. For the results, when you read slides for acid fast for Mycobacterium tuberculosis, there is a grading. And I will not discuss that here, okay? Bacteriology man to, para man ta. So, just give you a glimpse. So, the red ones there, they are your Mycobacterium tuberculosis. The causative agent of your TB, okay? And they're color red, okay? Later you'll know, okay? Ayan, and they are bacilli, they are rods, okay? Rods, pataas, rods, okay? Na bacteria. Alright, okay. Ayan, sige. Now, we go now to a diagram of how does the staining occurs. Okay. Ay, wala pa pala. Diagram lang of the mycolic acid cell wall. So, this is the cell wall of your bacteria that has mycolic acids or parasites. So, we have here, in normal bacteria, gram-positive, gram-negative, kuto pa sila here, dali lang, peptidoglycan na layer, okay? And in the gram staining results, it is in this layer that different bacteria have their differ in the content in the peptidoglycan. And dira na muna ang principle sa imong gram stain. Okay, in the peptidoglycan layer, no, for gram positive organisms, their peptidoglycan layer is thick, baga, okay? So they can take up the primary stain, which is crystal violet, so they appear violet under gram stain. So if gram stain bacteria, if you gram stain mga bacteria and then ang result niya kay purple or violet, then that's gram positive. Because its peptidoglycan is thick, it's able to take up the primary stain, which is crystal violet. Whereas your gram negative organisms, they have a thin layer of peptidoglycan. Thin, nipis lang. So they cannot really hold on to the primary stain, which is your crystal violet. So they take up rather the secondary stain, which is your safranin, which is red. That's why if a bacteria is subjected to gram stain and the result is color red or pink, pinkish or red, then that is gram negative. Ayan. So more of that with Ma'am Teddy in your intro to micro and bacteriology then. Alright, that's for gram staining. But for acid-fast staining, this is what we are looking at. The mycolic acids. So the non-acid fast organisms, okay, they don't have this part. I think dito lang, hanggang dito lang. Okay. Dira sila kutob, dira sila tama. Charot. Okay, alright. So these are the mycolic acids, again, long chain fatty acids. Alright, okay. Now go to the different methods in acid-fast staining. So there are a lot, no? As you can see, there are 4. And the 4th one is what we use for parasites. Because again, the parasites that we are going to stain or that we are going to look for are the coccidian oocysts, alright? The coccidians. They are, again, as mentioned, they're only modified. They're only partially acid-fast, okay? So, but again, so that you can appreciate it even more, we're going to discuss the first 3 methods. Wala pala to. Sorry guys, it's not included. Sorry. I did not include this. Sorry. Ito lang pala, 1 and 2 and number 4. Sorry. I'll just edit that. Sige lang. These are the methods, okay? But what we're going to discuss lang are the first 2 and not this one. Because this is, I'll reserve that for bacteriology na lang. Para at least may thrill konti. And then modified acid-fast. So these are the different methods for acid-fast staining. You have the hot method. Yan, hot like me. Char. The Zeal-Nielsen method, the cold method, the Kinyoon method, your Oramine rhodamine staining, and your modified acid-fast staining. Okay, now, ayan, so we have the hot method, cold method. Bakit kaya sila tawag na hot or cold? So we'll know later. So, so if may mga crush kayo dyan, mga conversation nyo, alam na. So, sabihin mo kay crush na, crush, bakit parang nagiging Kinyoon method ka na? Meaning, nagiging cold na siya. Char! Okay, joke lang. So, may mga crush ba dyan? Or kayo ba? Naging Kinyoon method na ba? Naging cold method na ba kayo? Okay, alright. Ayan, so baka naka-experience na kayo ng pagiging cold. Ayan, so pwede nyo nang i-change ang nickname sa conversation nyo na Kinyoon method. Basta kung cold na gani, painitin nyo! Mag-send kayo na charo joke lang. Okay, alright. Ayan, so we'll now go to the different staining methods. Starting first with your Zeal-Nielsen or your hot method, which is again the most common method then for acid-fast. Okay, but before that, we then go to the different stains, okay, that we use. The different reagents. Ako nalimutan, para hindi ko sige ano. Okay, alright. Now, these are the methods. These are the reagents. Kaya siya akong i-discuss na parts, these are bacteriology na gyud. So, I'm expecting that kung kinsa magani yung bacteriology teacher next sem, review na lang ito para sa inyo. Okay, so when you go to acid-fast staining na method, na topic, review na lang. It's going to be a review because I've already discussed it. Hopefully, I've discussed it well then. Or hopefully, I will discuss it properly or well. Alright, okay. Now, we have different reagents. Now, for differential staining, guys, no, dears, especially for, di ba, gram staining and acid-fast staining, we have additional reagents aside from stain. And what the stains or the reagents that I'm going to emphasize are number 1, the mordant, and number 2, the decolorizer. Diba? Na-mention na siya sa Tompkins-Miller method for iron hematoxylin, diba? So I mentioned I will discuss it now. So yes, so ito siya. Your mordant will serve as a reagent that will strengthen the relationship between the primary stain, which is carbylfuchsin in acid-fast staining, and your organism. Okay? And example, the long chain fatty acids or the structures that the carbylfuchsin is staining. So that's the purpose of the mordant. It strengthens the relationship between the primary stain and the organism that is stained. Okay? So it strengthens the relationship between, again, the primary stain and the organism. Now, the decolorizer, what it does is, basically, it's a reagent. I'd like to think about it as a reagent that tests, okay? It will now test the relationship between the carbylfuchsin and the mordant. Like, is it really able to capture the primary reagent? Is it really able to hold of the primary stain, which is carbylfuchsin? We add the decolorizer because it's through decolorizing that we are now able to divide the bacteria or the organism under study into the different groups, diba? That's the purpose of differential staining, diba? It's a staining method that can divide the bacteria or parasites into 2 groups, okay? And how do we do that? We accomplish that through decolorizing or decolorizer. And this decolorizing method or a stage is considered to be the most critical step. Ayan, nako, lumalabas din sa boards. The most critical step in staining, okay? In microbiology, bacteriology, okay? The most critical step in gram staining, acid-fast staining, what is that? decolorizer. Why? Because if it's too much decolorizing, pwede din na the organism should have been acid-fast in this case, meaning it was able to retain the carbofuchsin, but because of too much decolorizing, natangtang nun siya, or the carbofuchsin was washed out because of too much decolorizing. So that will lead to false negative results. Now, on the other hand, if it's under decolorizing or under decolorization, konti lang, alright, what happens is, instead that the organism is really not able to withstand or hold the carbofuchsin, because of little decolorization, it was able to retain lang yun, the carbofuchsin, because it was not that tested, or the decolorizing reagent was just little. So it will lead to false positive results, diba? So that's why it's called, or that's why it's considered to be the critical step for staining, in gram staining or acid-fast staining. Alright? So I hope na gets lang ang point sa decolorizer. It's the reagent really that we use so that we can divide na the two. Because when we add decolorizer, example, if it's really a true acid-fast, pag add sa decolorizer, wala lang effect. Like kiber lang, okay? Like bala ka dyan, okay? So the decolorizer will have no effect, diba, on our acid-fast, true acid-fast organisms, diba? So, dili mabungkag, the relationship between the mordant and the carbofuchsin will remain because again, strong our relationship, daghang long-chain fatty acids, alright? They were able to react, the long-chain fatty acids were able to capture and take hold of your carbofuchsin, no? So, bahalag kinsa pa ng mga third party dyan, na decolorizer, the relationship will not break, okay? So, it's able to take hold of carbofuchsin. So, that's true acid-fast. So, and if it's non-acid-fast, so pag butang sa decolorizer, weak ang ilang relationship, carbofuchsin with the mordant and the organism because the organism doesn't have long-chain fatty acids. So, of course, it will not be able to hold on to carbofuchsin that strong compared to the true acid-fast. So, pag add sa decolorizer, the carbofuchsin will be washed out. And pag add sa second stain, that organism will then take up the secondary stain. Okay? I hope na-gets lang. Sana naman. Alright, okay, that's for differential staining. Same procedure lang with gram staining. The difference lang are the reagents. Okay? Alright. Now, why is it called hot method? It's because the heat will serve as our mordant. That's why it's called hot method, because we use heat as the mordant. The mordant will, in a way, open up the cell wall of the Mycobacterium, because Mycobacterium, di ba, long-chain fatty acids. So, the cell wall is quite waxy. Maraming fats, medyo waxy. So, pag butang sa carbofuchsin, or when you add carbofuchsin, it will not penetrate that much. Because again, it's waxy, it's very thick. So, to open it up, medyo mas mo-open up siya. Okay? Alright, we then apply heat para mas musulod ang carbofuchsin. Okay? Alright, that's the purpose of of the heat. That's why it's called hot method, Zeal-Nielsen. Very common, the most common procedure of acid-fast staining here. In routine hospital labs, both Galeares and Soto, this is their method. Okay, alright. Ayan, and we have the contact time, which varies per manufacturer of the reagents. Okay, alright, so that's it. So we have a diagram. So as you can see now, let's say we have the reagent and let's say an acid-fast organism and non-acid-fast organism. So let's say your organism, of course, reagent is wala. You did not apply any reagent pa. So of course, the organism is not colored. Okay. Next, we then add carbofuchsin. Ayan. So what do you think will be the color of the two? Wala pa may decolorizer, wala pa anything. So what's the color? Of course, they will take up the color of carbofuchsin, which is red, both of them. Okay. Now, next reagent, your heat as mordant. Now, what's the purpose lang sa mordant? Just to strengthen the relationship between the carbofuchsin and the organism. Just to strengthen. So, do you think there will be a change in color? Strengthen lang man? Of course, wala. Because again, non-acid-fast, acid-fast, still the same. Both results. Why? Wala pa may decolorizer na gibutang. Diba? So, again, mordant just to strengthen the relationship, the initial relationship between the carbofuchsin reagent, your primary stain, and the organism. So therefore, the color is still the same. Ayan, nagets lang. Now, this is where the magic happens. O, diba? Acid alcohol is a decolorizer. So what happens, diba? Decolorizer. So siya ang third party. Siya ang test sa relationship between carbofuchsin and the organism. Is it really strong? Are you really true acid-fast? Are you or not? Are you a partially acid-fast or are you a non-acid-fast good? So let's say, pag add sa decolorizer, what do you think will be the color of acid-fast? because strong man yun siya, acid fast man yun siya, like real acid fast yun. Long chain fatty acids marami, mataas ang content sa kanyang cell wall ng long chain fatty acids. So strong ang pagka-bind between carbofuchsin and your organism. So pag-add sa decolorizer or your challenger, the third party, dili sila mabungkag. So therefore, your acid-fast organism will remain red. Whereas, for the non-acid fast, because again, weak ang relationship, the long-chain fatty acids are not really there, no? So, dali na siyang ma-trigger, dali na siyang ma-tempt by the challenger, which is your decolorizer. So, pag-add sa decolorizer, dili siya ka-retain much. It cannot retain the carbofuchsin because it has a weak relationship. Therefore, pag-add sa decolorizer, the carbofuchsin will be washed out. Therefore, it will be colorless na ang non-acid fast. Okay? And pag-add na sa secondary stain, either methylene blue or malachite green, depending. So for acid fast, since strong naman dyan ang since the relationship between carbofuchsin and the organism is really strong na, loyal na sila to each other, they don't want any other else, diba? So pag-add sa imong secondary stain, of course, they will not take it up, the organism will not take it up, and it will remain color red. Whereas for the non-acid fast, colorless man siya, brand new, yes, clean slate, ready to mingle, single, ready to mingle, yes, ready pa siya to accept a secondary stain. So therefore, pag-add sa secondary stain, either methylene blue ba or malachite green ha, either lang, either. You don't use both, either lang. Okay, so kung methylene blue, of course, the organism will be color blue, and if it's green, malachite green, the organism, non-acid fast organism, will be color green. Okay, so is it sure or cause? Parang ganun charot. Okay, alright. Ayan, so that's for the acid-fast staining for Zeal Nielsen. Now, for our primary stain, diba, it's carbofuchsin. Now, if you don't have carbofuchsin, you can use an alternative stain known as night blue. Okay. That's according to your book in histotechnology. I'm not sure kung unsay color nila. Baka blue din. Okay, but seldom lang siya ginagamit. Okay, just an alternative stain. But primarily good carbofuchsin. Okay, carbofuchsin. Alright, okay. So, nag-gets lang dears? I hope nag-gets lang dears. Alright, okay. Now, we go now to the cold method, which is your kinyon staining. Yung conversation ni Crush. Charot. Cold na ba? Oh, biyain na. Charot. Okay, alright. So, for cold method, same procedure, same stains. But for primary stain for cold method, carbofuchsin, increased concentration of phenol. Alright. And the difference lang is for the mordant because cold man siya, so it doesn't use heat. But instead, it uses a tergitol. Okay, and the tergitol is a wetting agent, so cold, that is already incorporated in carbofuchsin. Okay, so you don't need heating, alright? So pag add mo sa carbofuchsin, it already has tergitol, which serves as the mordant. Okay, that's why it's called cold method. Okay, and lastly, you have decolorizer is still the same, acid alcohol, hydrochloric acid plus 95% ethanol, and your secondary stain, or you can use your 25% sulfuric acid, and the secondary stain is still the same, either methylene blue or malachite green. Okay. Now, the third procedure that I guess is auramine rhodamine. Okay, auramine rhodamine. Okay. Now, this procedure, guys, or staining method, dears, this is a fluorescent method. So, fluorescence. So, you use a fluorescent microscope, okay? So these are fluorescent stains that will bind to the organism, and then once you examine it under the microscope, they will fluoresce, okay? They will give a light. They will give light, fluorescent light. In the color of auramine rhodamine, usually the Mycobacterium will appear parang orange ba yun? Or parang yellow, if I'm not mistaken, okay? Orange or yellow. Okay, they will fluoresce. They will emit light, color orange or yellow. That's auramine rhodamine staining. Okay, for Mycobacterium usually. Alright, okay. And lastly, we go now to the modified acid fast, which is of course what we are after. And dami nating chika. Ito lang pala yung kailangan natin. So at least now you understand, di ba? Hopefully naman. Why is it called modified acid fast or acid fast? Okay. Now for modified acid fast, we use this procedure for, again, the partially acid fast organisms. And who are those? You have, again, Nocardia, Gordonia, Rhodococcus, and Chucamorella. Corynebacterium and Legionella micdade. Sorry, wrong spelling. Micdade na siya, sorry. Micdade. Okay. The bacteria that are partially acid fast, meaning they have mycolic acids in their cell wall but in a lesser content compared to Mycobacterium, which is the true acid fast. Okay? So partially acid fast, mnemonics for that for me is NGRT. Okay? Nocardia, Gordonia, Rhodococcus, and Chucamorella, which are again partially acid-fast organisms. Additional is Corynebacterium, lumabas sa boards namin. The question was, which of the following organisms cannot be stained with acid-fast? Okay, or which of the following organism does not have mycolic acids yata? I think cannot be stained by acid-fast. And the choices are Corynebacterium, Nocardia, Rhodococcus, and Streptomyces. Okay, so the answer there is Streptomyces. So Streptomyces do not have mycolic acids in their cell wall. So it cannot be stained by acid-fast staining. Okay? Because Corynebacterium, if you don't know, example, Corynebacterium good is you wouldn't think that it has mycolic acids, but according to Bailey and Scott's, it has mycolic acids, Corynebacterium. Under normal circumstances, if you haven't read Bailey and Scott's, if I haven't read Bailey and Scott's, I would answer Corynebacterium. But according to Bailey and Scott's, it has mycolic acids. Streptomyces ang wala. So, ang answer ato is Streptomyces, which natama ko naman. Thank God. So, Streptomyces does not have mycolic acids. Corynebacterium, guys, it has. Please take note. Again, board exam question. Recall sa time ko. Okay? That during my board exam. Alright. Okay. And for parasites, what we're really after are your coccidian oocysts, Cryptosporidium, Cyclospora, and Cystoisospora. Okay, silang tulo. I've discussed about Cryptosporidium yata in the life cycle of where did I discuss that? Basta I've discussed Cryptosporidium na life cycle. Quite the same naman, ingestion usually. Silang tulo, ingestion of food or water. Example for Cyclospora cayetanensis, Cyclospora cayetanensis can be transmitted through the eating of raspberries. Oh my gosh, lumalabas. Please take note, raspberries. So mga case studies dyan, a person has ate raspberries and after a while diarrhea siya, intestinal symptoms, whatever. You can think about Cyclospora cayetanensis. There's an episode of Monsters Inside Us, the one that I've been talking about na show sa Discovery Channel. Ang ilahang positive agent is Cyclospora cayetanensis. And where did they get it? Where did they get the Cyclospora? Outbreak siya. They got it from raspberries because it's a group of parang mga pharmacists that they went on a parang meeting and then they have this dessert na meron cream and then na ay raspberries na raw. Wala siya gi-eat. O, diba? So what happened? After a while silang tanan ni kaon ato nagkalibanga. And what they discovered was Cyclospora cayetanensis. Yes, it's all real, guys. Totoo lahat. Lahat ng mga pinag-aaralan nyo, it's all real. Okay? Alright. Another characteristic of Cyclospora cayetanensis na lumabas din sa boards is that it exhibits autofluorescence. Naku, oh my gosh. Dami ko na mga recall questions na sinasabi. Autofluorescence. Ayan, please take note. What do you mean by autofluorescence? In itself, mag-emit siya of light, okay? Even without adding auramine, rhodamine, the stains, even without adding any stains to fluoresce or without giving it energy. In itself, muhatag siya of fluorescence. It emits fluorescence light, okay? Who is that? Autofluorescence? Cyclospora cayetanensis. Please take note. Okay, alright, ayan. So these are your coccidians. Your coccidians, again, are protozoan parasites. Usually, they are transmitted through ingestion, okay, of contaminated food and water. So fecal pa rin. Alright? Tapos, generally, mas devastating ang effects, especially Cryptosporidium, for those that are immunocompromised. So, mga HIV/AIDS, those that diseases or patients with immune system na depressed, okay? So, very, very devastating ang effects doon. Diba? Yung chika, another episode din in Monsters Inside Us, Cryptosporidium, water outbreak. It's through water. Okay, alright. So, these are all your partially acid-fast microorganisms, bacteria and parasites. Alright. Now, the decolorizer is, as you can see, 2% sulfuric acid. That's why it's called modified acid-fast. It's because the decolorizer is much weaker. It uses a weaker decolorizer compared to the true acid-fast procedure. That's why it's called modified. Lumabas din sa boards. What is the difference between the modified acid-fast and the true acid-fast stain? The modified acid-fast uses a weaker decolorizer. Okay? Because again, as mentioned, small content of long-chain fatty acids for these organisms. So you don't use a strong decolorizer. Kaya ma-over-decolorization na, So therefore, it can lead to false negative results. We cannot see them anymore. So instead of using the stronger decolorizer that is used in the true acid-fast staining procedure, we just use a weaker decolorizer to compensate, okay, or to partner their small content or low content of long-chain fatty acids in their cell walls. Okay? Alright, ayan. So that's why it's called modified acid-fast. Why is it called modified acid-fast? Because it uses a weaker decolorizer, mas weak, less concentration, weaker decolorizer than the true acid-fast staining or the original acid-fast staining procedure. Okay, ayan. Ayan. Gentler decolorizer avoids over-decolorization or weaker decolorizer. Alright, now here is your results. Still the same. An expected color. Okay, so positive for name of parasite and stage, positive for Cryptosporidium parvum, Cryptosporidium SPP oocyst, and then negative for Coccidian oocysts. Diba? So if na kay Beshi, yan na yung mga tanan mo, like oocysts. Okay. Mukha ka ron, oocysts. O, diba? Ayan. So, one Coccidian to another or one Beshi to another oocyst. Kung mo-agree mo. Charot. Okay, Mark. Sige na, daming joke. Okay. Alright, so ang color again, pink to red. So it can be pink because again, lesser. Pwede pong red. Alright, of Cyclospora, for Cyclospora variable, clear to pink to red. The yeast and background material, as I mentioned, non-acid fast organisms, they will take up the secondary stain. Could be methylene blue, or again, red. Green, sorry, kumalaki, green. Okay, background material, blue or light red. Basta, dili totally red. Okay, basta usually blue lang na siya. Alright, or green. Okay, now here are some of your pictures. Ayan, so as you can see, these are your Cryptosporidium. They are spherical, the oocysts. You have Cyclospora and you have Isospora. Diba? Cysto-Isospora belly. The ones that I let you see under katatong virtual microscope activity. Diba? So if you remember ninyo. So they appear color red, pink to red, and a blue background. Okay? Alright. Ayan. So those are your parasitic oocysts. Again, that's what we use our modified acid fast for. Okay. Alright. And that's the end. Oh my gosh, I-push na rin ako, but very, very stressful ang mag-record in this balayan. It's so hot yun, guys. Walang aircon. Poor. Aircon. Okay, but anyway, sana naman, I hope lang yun that I was able to discuss this topic properly. Medyo may mga sabaw na discussions, but I hope lang yun naka-discuss na po properly. If you have any questions, feel free to chat me or chat in our group chat. Okay? And then we're almost done. Konti na lang na mga lessons, topics, guys, and we're almost done yun with Para. Okay? Alright, ayan. And I hope you're all doing well. Laban lang yun. Gamay na lang, no? Now is not the time to give up. Push lang yun. Okay? Alright. So, again, I hope na-discuss lang na ako, ha? So, do not be shy. Ayun mo ka shy. My gosh, kapit na mo na Sem. Maulaw pa mo. Okay? Just to ask questions if you have any questions. Okay? Alright. So, that's all for this pre-recorded lecture, guys. I'll see you in the next pre-recorded lecture. Hapit na yun at the remaining topics. Thank you for watching. Have a great day and keep safe.